Hey, 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 what is up? This is your DJ Athens at the top of the hour here at Metro Davao City. No, I'm just kidding. I'm your classmate Athens, and I will discuss about flame photometric detector. Before we begin to our objectives, I will tell you the definition of flame photometric detector. Therefore, flame photometry is defined as the measurement of intensity of the light emitted when any alkali or earth metal is introduced into the flame. And to add more of that, I'll give a brief background about this, but I'm sorry if I don't have any pictures of the people I will be announcing. But during 1980s, Bowling Barnes, David Richardson, John Barry, and Robert Hood developed an instrument to measure the low concentrations of sodium and potassium in a solution. They named this instrument as dun, 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 flame photometer, or for short, we'll call this FPD from now on. Before we dive into this topic deeper, let me inform you the learnings we need to tackle in this video. Now, I will explain the mechanism of detection of a FPD, enumerate the type of compounds that can be detected by FPD, identify what type of detector is FPD, and lastly discuss the characteristics of a FPD. Now, for Windows students, you can browse or open your 7th edition Harry's book, page 544, for furthermore details about this. Yes, we are here and the mechanism. Please bear with me. This is kind of a bit lengthy, but I hope you will listen. Now, this device uses a chemiluminescent reactions of compounds in a hydrogen or air flame as a source of analytical information that is relatively specific for substances containing atoms. The primary combustion zone of the flame is blue in color. In this region, there is no thermal equilibrium. Therefore, it is not used in flame spectroscopy. The interconal region is rich in free atoms and is the most widely used region for the spectroscopy. I'm sorry. Now, proceeding, there are basic ports. Oh, I hope you will remember this. Now, the flame, this one, is a burner that is within the instrument, of course, needed for temperature control and to heat up the solution. Now, the nebulizer breaks up the sample into atoms. I assume it will be around here. Now, the mixing chamber, yes, around here, mixes the relevant solution with the sample. Now, the color filters around here shows us which metals are present. Now, the photodetector is around here. I'm sure for that. And this tells us which metal the sample contains and to what concentration level. In addition to the instrumental requirements, there's combustion chamber to the house of flame, gas lines for hydrogen fuel and air oxidant, and exhaust chimney, yeah, here, to remove combustion products. Now, the final component necessary for this instrument is a thermal bandus filter to isolate only in the visible and UV radiation emitted by the flame. Without this, large amounts of infrared radiation, oh no, emitted by the flame's combustion reaction would heat up the photomultiplier tube, this one, PMT, let's call this PMT, and increase its background signal. Now, the PMT is also physically insulated from the combustion chamber by using purely thermally conductive metals to attach the PMT housing, filters, and etc. Now, in order to selectively detect one or the other family of compounds as it elutes from the GC column, an interference filter. Now, this one is used between the flame and the photomultiplier tube, PMT again, to isolate the appropriate emission band. The drawback here being that the filter must be exchanged between chromatographic runs if the other family of compound is to be detected. This then tells us which metals are in the substance we are testing, and to what concentration is. Now, I will be summarizing the process that is occurring during a flame photometer analysis. I believe you already heard these terms, but I will repeat it for the sake of FPD. Now, desolvation. Desolvation involves drying a sample in a solution. The metal particles in the solvent are dehydrated by the flame and the solvent is evaporated. Now, you can imagine that. Evaporation. Now, the metal particles in the sample are also dehydrated. This also leads to evaporation of the solvent. Now, atomization dun, 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 is the separation of all atoms in a chemical substance. The metal ions in the sample are reduced to metal atoms by, of course, the flame. Now, excitation. The electrostatic force of attraction between the electrons and nucleus of the atom helps them absorb particular amount of energy. The atoms then jump to the higher energy state when excited. Now the last one is emission. Since the higher energy state is unstable, oh no, the atoms jump back to the ground state or low energy state to gain stability. This jumping of atom emits now the radiation with characteristic wavelength. The radiation is measured by the photodetector. Now the question, why calibration of flame photometer is important? Of course, the most important part of calibrating a flame photometer is to have a point of reference for a reading. Without a point of reference for a specific quantity of light absorbed by the ions, the results are meaningless and nothing more than a measure of current through a photodiode. Now, thank you. If you had a hard time understanding or imagining what I've just discussed in the previous slide, thank God this video exists because this will help you understand and imagine the things I've discussed.
Describe in brief
clearly.
the main components of the flame
I will play for
photometry.
you.
The main components of the flame photometries are as follows. First is the burners. The temperature of the burner must be more than 2000 degrees Kelvin. Burners used are of two types. One is total consumption burner and second is premix burner. So let's talk about total consumption burner. As the sample solution is completely burnt, so it is known as total consumption burner. The fuel which are used in this case are acetylene, propylene or hydrogen. The fuel is oxidized by oxidizer, which are either air or nitrous oxide or oxygen diluted with nitrogen. When the fuel and oxidizer are burned at the tip of the burner, the large amount of heat is produced. So the air present in the capillary expand, creating a partial vacuum in the capillary. Because of vacuum, the sample solution is rushed to the tip of the burner. Now the principle starts. The sample is broken into the fine spray at the upper tip of the capillary and then mixed with the gases and are burned. This process is known as nebulization. In the principle, some of the gaseous metallic atoms absorb the heat energy. So transition takes place from the ground state to the excited states. When the excited atoms return back to the ground state, they emit the radiations. So let's talk about the merits and demerits of this burner. First, the flame obtained is turbulent. Second, it is noisy. Third, it has small area of cross section. And the last, it is used for most type of the flames. Now let's talk about another type of burner, that is premix burner. In this case, sample solution, fuel and oxidizer are well mixed with the help of axle, having the baffles. In this case, only a small droplets of sample can reach to the flame and large droplets of the sample is collected at the bottom in drain. Only 5% of the sample is burned, whereas 95% is condensed and drained out. These burners are also having some merits and demerits. So first, flame produced is non-turbulent. Second, the flame is noiseless and stable. Third, it has large area of cross section. And the last 5% of the sample is burned while 95% is drained. So let's discuss other component of the flame photometer. These are concave mirrors. All the radiations which are emitted by the excited atoms are collected by the concave mirror and are passed to monochromators. Next comes monochromators. The radiations are dispersed into the different wavelength by rotating the prism or monochromator. The radiations of one value of wavelength are incident at a time on the photocell. Then it comes focusing convex lens. It collects the radiations coming from the monochromators and allows them to fall on the detector. Photocell. A beam from monochromator falls on the photocathode of the photocell. The current is recorded. The magnitude of electric current is directly proportional to the concentration of the solution. The photocell used is PMT or photomultiplier tube. And finally, there is readout meter. This meter gives us directly the intensity of radiation which is emitted by the excited atoms when they return to the ground state. Let's discuss the working of this instrument. When the fuel is burnt at the tip of the burner, the sample solution rushes upward and then solvent is vaporized and the solid molecules are produced. These solid molecules are then converted into gaseous atoms. Some of the gaseous metallic atoms absorb heat energy and jump to the excited state and instantaneously return to the ground state with emission of radiations, which are collected by concave mirrors and are incident after passing through monochromators. The current is produced in the photocell and it is connected with a readout meter, which gives us directly the intensity of the radiations emitted by the excited atoms. From the intensity, we can have the quantitative analysis.
I hope this video gave you a clear image of what I was discussing about. Wait, what? You're still having a hard time understanding what I've just said? Chill, I will be giving you less than a minute, or you can even pause this for you to digest what I've discussed and the video discussed. Hey, look at that. The art is so cute. Anyway, now we are here at the compounds that can be detected. As you can recall what I've just said earlier, that it is any alkali or earth metal. Well, most of the time there are two components as defined or determined. Now, determination of sulfur or phosphorus containing compounds is the job of the flame photometric detector, FPD. Now, in addition to that, any individual selected elements such as phosphorus, sulfur, tin, and lead. Would you look at it? We are at our third objective, which is to identify what type of detector is FPD. Now, it is one kind of detector for gas chromatography. The reason to use more than like one kind of detector for gas chromatography is to achieve selective and slash or highly sensitive detection of specific compounds encountered in particular chromatographic analysis. Now, flame photometry is one of the branches of atomic absorption spectroscopy. No wonder it has similarities with it. It is also known as flame emission spectroscopy because of the emission of radiation. Currently, this has become the necessary tool in the field of analytical chemistry. Yay, we are at our last objective, the characteristics. Now always remember that there are four basic components to a flame photometer: a flame, nebulizer and mixing chamber, color filters, and a photodetector. Now let's proceed to the disadvantages. Number one, the accurate concentration of the metal ion in the solution cannot be measured. Number two, it cannot directly detect and determine the presence of inert gases. Number three, though this technique measures the total metal content present in the sample, it does not provide information about the molecular structure of the metal present in the sample. Number 4, only liquid samples may be used. And number 5, flame photometry cannot be used for direct determination of metal atoms. Several metal atoms cannot be analyzed in this method. Now the question why flame photometer is not used for nonmetals, it is because metalloids and not metals generally do not produce isolated neutral atoms in a flame, but mostly as a polyatomic radicals and ions. Therefore, nonmetallic elements are not suitable for determination by flame emission spectroscopy, except for a very few and under very specialized condition. Now let us look at the brighter side, the advantages. Now number 1, the method of analysis is very simple and economical. It is quite convenient, selective, and sensitive analysis. Number 2, it is both qualitative and quantitative in nature. Number 3, even very low concentrations, parts per million, parts per billion range of metals in the sample can be determined. Now, number 4, this method compensates for any unexpected interfering material present in the sample solution. And last but not the least, the method can be used to estimate elements which are rarely analyzed. I am so sorry guys to add this tiny little bit information slide to you guys, but this important like the applications. Yeah. Now, the flame photometer can be applied for both quantitative and qualitative analysis of elements. The radiations emitted by the flame photometer are characteristic to particular metal. Hence, with the help of flame photometer, we can detect the presence of any specific element in the given sample. Now, the presence of some group 2 elements is critical for soil health. We can determine the presence of various alkali and alkaline earth metals in soil sample by conductive flame tests, and then the soil can be supplied with specific fertilizer. Wow! Now, the fourth, the concentrations of sodium ions and potassium ions are very important in the human body for conducting various metabolic functions. Their concentrations can be determined by diluting and aspirating blood serum sample into the flame. Now, our favorite, our vices, our hobbies like drinking soft drinks, fruit juices, and alcohol beverages can also be analyzed by using flame photometry to determine the concentrations of various metals and elements. Thank you guys for listening. Now this is the credits and references. Now, peace out guys. Hey.